Hello, welcome to Lotus tutorial, complete C Sharp, lesson 6, part 2, operators in C Sharp. In this session, we are going to learn about the operators in C Sharp. In the last session, we learned about the first three operators, and right now we are going to concentrate the rest of them. They are logical, short circuit, and the conditional operator. The logical operators includes and, or, exclusive, or, not, short circuit, and, or. Okay, these are the operators come under logical, and this is the working nature of the logical operators and, or, not, exclusive, or. So and is going to provide us the result true when both of the inputs are true, and or is going to provide us the value true result as true only when any one of them are true or both of them are true. So and exclusive or is going to provide us the result as true when any one of the input is true or either or false. Okay, and not operator is completely different. If the input is false, it provides you true, and if the input is true, it provides you the false. Okay, now let me show you the working of exclusive or and not or and other operators right now. So let me take boolean values true, and let me take b false. So if I'm going to specify if a and b it's something like if a and b, then only I'm going to, if a and b are true, then only I'm going to provide you the output. So I'm going to provide the output as 1, else I'm going to provide the output as here. Let me go give it as true itself. Let me copy and paste just to save the time, and here the value is false. So you can observe the value of a and b are true and false respectively. So if a and b, okay, so what I'm trying to do is if a and b are true, then I'm going to execute this statement or I'm going to execute this. So the implementation is very simple. And operator is going to provide us the result true only when both the inputs are true. So here both the inputs are not true, they are true or false. So let me run the application. I'll get the output as false as of now. Now if I make it as true, the second value also, then I'm going to get the output as true. This is what about how the logical hand works. Now let me show you OR. Okay, now when I do control F5, I'm going to get the output as true, in the sense and is going to, or is going to provide us the output true when both of the inputs are true. And now if I make them false, now let me, okay, it's going to provide us true, in the sense and is going to provide us the output as true when both of them are true or either of them are true or false. If both of them are false, we'll get the output as false itself. Observe, we're getting the output as false. Okay, this is what about OR operator. Now I want to show you about exclusive OR. So it's just going to provide us the output as true only when either one of them are true or false. So if I set both of them to true, then also I'm going to get the output as false only. Now also I'm going to get the output as false, you can observe. And now if I set any one of them to true and other one as false, then I'll get the output as true. Okay, this is what about the exclusive OR. And now let me show you about not operator. Now what is output I'm going to get? Since, let me remove this, control F5, we are going to get the output as true. But if I make use of this not operator here, okay, what is output I'm going to get? It reverses the input what it is having. It provides the output as false as of now. You can observe very clearly. Just reverse the input whatever you provide to it. Suppose if I set to false, then I'm going to get the output as true. Okay, this is what about the not operator is. And apart from that, we have the other two operators, they are short circuit OR and short circuit AND. Okay, this is somewhat related to this AND and OR operator. Now let us check how it is related and how it is efficient than AND and OR. So what I'll do is, let me initialize some variables n comma d. So what I'm trying to do is I'm trying to specify the value of n as 10 and the value of d as 2. So I'm using if condition statement here. So what I'm trying to do is I'm going to check, like, if d is not equal to 0, d not equal to 0, then okay, now what is the specialty of this AND? Okay, then what I'm trying to do is, then I should get like n modulus of d. Okay, n modulus of d, it should be equal to 0. Okay, then print telling like d is a factor of n. Okay, int n is equal to d, n10, d2. If d not equal to 0 and n modulus of d equal to 0, print this is a factor of 10. Now else it has to, okay, not a factor of n. So now when I run the application, okay, now I'm getting like d is a factor of 10. So what's happening right now here is, the value of d is 2 and I'm checking whether 2 is equal to 0 or not. No, it's not equal. So what happens here is it jumps to next statement. Okay, and here it will check whether when I divide 10 by 2, am I going to get the output as 0? Yes, the remainder I'm going to get it as 0. So okay, n modulus of 2 is 0. Okay, and this condition passes, so I'll get the output as d is a factor of n. In a sense, 2 is a factor of 10. Okay, and now what I'll do here right now is, now I'll set the value of d to 0 right now, and now okay, I'm specifying it here. So now what I'll do is control Fi. D is a factor of 10. Okay, when it is factor of 10, when the value of, okay, let me show you here, when the value of d is 2, d is a factor of 10. So as soon as I set the value of d to 0, it is telling like d is not a factor of n. Why? Because here what's happening right now is, and what is the advantage of using this? So let me remove this, let me show you here itself. So now when I run the application, it will tell like d is a factor of 10, that is 2 is a factor of 10, and that's fine. Now what I'll do, I'll set the value of d to 0, so I'll get the output as d is not a factor of 10. Why? Because now the value of 0 is, d is 0, so 0 not equal to 0, and here the condition is failing. Okay, and so what it does is, if I use this operator, it's not going to check the next condition because the condition is failing at the first stage itself. So when I use this operator, logical and, what it does is, first it checks the first condition. If the first condition is passing, then only it will pass to the next condition. If not, it just comes to this else loop. So this is the advantage of using this logical AND. Now let me show you this. I'll make use of only AND operator. Now let us see what is the output we are going to get. We are going to get some output as some exception, telling like divide by 0 exception. You can observe very clearly here. Okay, why we are getting this exception? Because the plain AND operator, what it does is, it checks this condition. Okay, d not equal to 0, then obviously 0 is not equal to 0. Okay, so what it does is, this AND operator, it will come to this condition also. So here it's checking like n 10 divided by 10 modulus of 0 is equal to 0. So we can't divide a number by 0, so we are getting that exception. But when I make use of this logical AND, we are not getting this exception. Why? Because what logical AND does is it checks the first condition. If the first condition is passing or it's qualifying, then only it allows to check the next condition. Okay, that is a specialty or the difference between simple plain AND and the logical AND. Okay, and that's what now we'll get the output as d is not a factor of 0 is not a factor of n. And if I make use of this, and we'll get the output as divide by 0 exception, because it allows to check the next condition also when the first condition is failing. I hope you understood, and if you're not if you're and I think like you can try with this one, this logical OR. Okay, now let me jump to this conditional operator or the ternary operator. So here comes the ternary operator is often used to replace certain types of if then else constructions. So this ternary operator, it requires 3 operands. It is called ternary because it requires 3 operands. The general form is expression 1 is evaluated. Based on the evaluation, it's going to take expression 2 or expression 3. So now let me show you this one. It's very simple. Now what I'm trying to do is I'll take int a is equal to 10, int b equals 5. In the if condition, I'm going to specify if a is greater than b. Okay, print the value of a, else print the value of b. I do this, I'm going to get the output as 10. Now what we are doing is we are almost writing some 10 lines of code to get this to check this condition, and we can avoid this. We can avoid this lines of code by writing this lines of code in a single line. How can we do that? With the help of this ternary operator. So what I'll do is I'll take a variable called result. In that result, what I'm trying to do is I'm going to first check the condition if a is greater than b. Okay, and after that I'm going to tell a equal to b. Okay, control S. Now when I what I'm trying to do is when I run the application, I'm going to get the output as 10. So what's happening right now here is we achieved the same thing what we achieved using if else loop, if else condition statement. With the help of that, we are achieving this in the same manner. What happened here is how it evaluates. First is check the condition. If this expression is true, okay, if the condition is going to pass, then it's going to store the value, or it's going to execute this part. Okay, if the condition is failing, it's going to execute this part. So as of now, a is greater than b, it's going to fetch the first part, that is a. So we are getting the output as 2. Now let me interchange. Now a is greater than b, this condition fails, so it jumps to the second part after this colon. So we'll get the output as 20. Okay, this is the advantage of using this ternary operator, which reduces the workload of if else condition statement. So now let me jump back, and this is what we learned in the last 2 sessions, like operators in C#. Okay, and we completed that very successfully. And finally, thank you for listening.